Yeah, once again, welcome to Physics and Chemistry Made Easy. Now, in my previous video, I have explained you the formation of images, right? The characteristics of the images in case of a concave and convex mirror and all that. Now, we'll see ray diagrams for different object positions and the different image positions. Now, as I told you already, cave mirror, concave. I told you to remember cave means you have plenty of animals inside it, lion, tiger, and along with that. So you remember 6 images. Vex means it is one image. Actually, there are two concepts. One is 1 and the other one is 6. So let us give concave 6 images and convex is 1. Very nice, good. Now I'll explain you image formations in a concave mirror. This is a concave mirror. As I was telling you, a reflecting surface is inside. Okay, done. This is a sphere actually. This is a sphere like this. It's a sphere. Therefore, you will find this as point C and this is point F. To get proper images, what you are supposed to do is, you should take this distance and this distance equal. Say 2 centimeters, then you take this also as 2 centimeters. You will get proper diagrams. That is one thing. Other thing is, draw this curve with the help of say a 10 rupees coin or else a compass, or else better way, you can even use the lid of bottle. Very good. Right, now let us see. So first case I told you, object is at infinity, and like this, object at infinity means we have to draw parallel lines, parallel lines. What happens when the object is at infinity? All these lines actually get converged at focal point. So you get an image here only. You will get an image at focal point. Is it falling inside the mirror? No. See, once I told you very clearly, once again I am telling you, if you are between F and P, this is P and this is F. If you are between these two only, your image will be seen in the mirror. Other cases, your image will not be seen in the mirror. So this is first case. Now what is the characteristics of this image? Point size image. Point size image. How to catch this image? You have to use a screen over here. You have to use a screen. Done. Then next one. Concave mirror, colored outside, focal point C. Object is at beyond C. Object is beyond C. What did I tell you? If the object is on C, you will get image on C. If the object is towards right side, you will get image towards left side. If the object is towards right side, left side of this C, then you will get on the right side. Image will be on the right. Just opposite. They move reciprocal. Okay. Now coming to this image formation, you require what? Ray diagram. So you have to show parallel. First rule, parallel through focal point. A line which is drawn parallel to the principal axis, after touching the concave mirror, it will go through focal point. Now a line which is passing through focal point, it goes parallel. There you got the image. Just now very clearly I told you, if the object is on C, you will get image on C. Now the object is on the right side, therefore image is on the left side. Now you tell me, is it inverted? Yes. Inverted is what? Here. Good. Then is it of same size? Object size, image size is same? No. Therefore it is diminished. Now what to do? I told you, no, real inverted means minus. Diminished means less than 1. Less than 1 means 0.1, 0.2, 0.3 like that up to 0.9. Finish. Now catch the point. These ray diagrams. Parallel through focal point, parallel. These are your ray diagrams. Just remember, parallel through focal point, parallel. Now coming to the second position. No, third position, sorry. First is infinity, then beyond C. Now it is on C. And once again, let me tell you, if you can maintain this distance equal and proper curve, you will get good diagrams. So now the object is on C. When the object is on C, where will you get the image? On C. Very clear. On C, on C. Now, what are the things? Parallel. First rule, parallel through focal point. Through focal point goes parallel. So you got it. You got the image. On C, on C. What are the characteristics of this image? Real, inverted, same size. Yeah, very good. Real, inverted. Because it's inverted. Like this boy, inverted. And it inverted is always real. Now what happened? It is of same size. On C you will have same size. Real inverted is expressed with minus. Same size is expressed with 1. This is the magnification value of object If the object is on C, you will get image on C, and the magnification value is -1. Minus indicates real inverted, 1 indicates same size. Now where will you get this image? On the screen. On the screen, yes, real images are caught on the screen. Where is the possibility to get into the mirror? No, it is falling outside the mirror, isn't it? Therefore, you require a screen to catch this image. Good. Then comes fourth position. Yes, focal point, and this is C. This is here. Object is here. What is this position called? Object between C and F. I told you, no, if it is on C, you will get it on C. If the object is that side, image will be this side. If the object is this side, then image will be on the other side. Now you will get beyond C, and the image which is going beyond C will be bigger one. Now what to do? Same. Lines are same rule. Rule 1, parallel through focal point. Through focal point goes parallel. See, excellent you got here. If you try to get here also, you will not get, because this is pakka, no. If object is coming closer to the mirror, therefore image moves away from the mirror. So this position is called what? Beyond C. Image position is beyond C. Now you tell me object, this is object and this is image. So it is object and this is image. Image is much bigger than object, therefore it is called enlarged. But is it erect? Erect means like this, erect. Why standing like this? No, you are getting it is inverted. Inverted is always real. That much only. Inverted is always real. Now invert, how to represent invert? Invert minus. Invert real are represented as minus. Invert real. Enlarge means greater than 1. Greater than 1. In previous video I clearly showed you whether -1 is greater or -2 is greater. It is -2. It's not number line, it is magnification. -2 indicates that the image is inverted and 2 times greater than the object. 2 times greater than the object it is telling. What does this indicate? Real inverted. It indicates that it is a real and inverted image. That's all. Minus indicates it's inverted image. These are the values given. Right? Inverted is always real. Good. Now the next one is what? Object on F. Object on F. Where will you get the image? Infinity. Infinity. You will get the image at infinity. Now drawing lines. Remember. Infinity. Okay, good. Very good. Beyond C. First two rules we used: parallel through focal point, through focal point, parallel. On C we have used the same rule: parallel through focal point, through focal point, parallel. Between C and F also we have used the same rule: parallel through focal point, through focal point, parallel. Now what happens when you are discussing with point C and point between P and F? This is P. If you come across next point P and F, you have to use first rule and third rule. So the first rule is what? Parallel through focal point. And the third rule is what? Through C. Remember this one? That rule you have to use. Simply you have to show and leave it. It is at infinity. Image is formed at infinity. That much only. Once again, object beyond C, on C, between C and F, you have to use the first two rules. Rule 1, parallel through focal point. This is your rule 1 only. Rule 2 is what? Through focal point parallel, you have to use beyond C, on C, and between C and F. When you come across this point, you should not use your rule 2. The characteristics of this image is infinity. Now coming to a very important means very important actually I can say. Right, this is, as I told you, F, and this is C. Once again I am telling you it's a sphere. Therefore you will find this inside. And focal point is in front of the reflecting surface, so concave always focal point is negative. That is understood. Right, now object is here. Do you remember? Just now I said if you are on F and between F and P, this is called P. When you are drawing these diagrams, you should not use second rule. Right, first rule, parallel. Yes, first rule let me draw with a red pen. Parallel, okay, parallel. So it is going through focal point. First rule is over, good. And I said you should not use second rule. So you have to take a scale. From here you point out these two dark, place the scale and draw. Now don't lift the scale. Extend these points straight away. Don't lift the scale, I said. Don't lift the scale. Just extend these points like that only. Now you extend this also by putting the scale. Don't bend it, just extend it like this. So these two here you are meeting, you have to draw a dot in. This is erect position. And just now I told you, if you go to a exhibition, the moment you enter inside, there will be a plane mirror. You along with your father, you will feel very happy to see your images in the mirror. When you turn right side or left side, according to the arrangement, there will be a concave mirror in front of you. You can clearly see there is a mirror in front of you, but your images are not seen. Quite natural, because I told you, no, your images will, if you stand in front of this mirror, images will not form in the mirror. All the images are caught on the screen. When the object or you are between P and F only, your image will be seen in the mirror. Now that image is erect, so you are like this now. You are here like this, erect. Okay. Erect is always virtual. Erect is always virtual. And this is enlarged, isn't it? This is object and this is image. So size of the image is much more greater than the object. Therefore, it is called enlarged. Virtual, erect, and enlarged. So what do we say? Virtual erect, we represent it with plus. Enlarged means we represent more than one. Finish. These are the ray diagrams. Very easy to understand. These are the ray diagrams. Now what else? Convex. We have got one more mirror, and that is convex mirror. And how many images do you find in convex mirror? Only one. I'll show you. This is a convex mirror, colored inside. This is the principal axis, and I told you this is sphere, on this side sphere. Therefore, you will find F and C inside. It all depends upon the coloring. Sphere remains the same. Now let us take the object. You can take the object here. You can take the object here or somewhere. No problem at all. You will get only one image position, and that will be between P and F. Between this P and F. Here you will get the image here. Always you will get it there. Now we will see how. So you take anywhere. You take the object position anywhere. So let us take the object position is here. So line, parallel. Chalo, through focal point. Yes, do you remember first rule? Rule 1. Then put a scale from here to C. Just straight line. Just draw, and it has to intersect or coincide C. See, here you got the image. Where this point? Yes. I was telling you now that you will get image between F and C. Suppose the object is here. Same. Only thing what happens, tell me, little bit bigger you will get, because the object has come closer. Little bit bigger. Suppose the object is here. Same, parallel through focal point next to C. So what is that? You will get little bit bigger, but always between F and P. And one more thing. It's never image size and object size is not same. Never it is. Image size and object size is never same. Never. So what happened? It is what? Because it's now like this, isn't it? Image is like this, but a shorter one. Anyhow, erect one. Erect is virtual. And it is not of same size with the object, therefore it's called diminished. That's all. These are the characteristics of the image formed by a convex mirror. Virtual erect, what do we do? Virtual erect, we write it plus. Diminished means again, we came back to diminished, less than 1. So it's plus, virtual erect, diminished. Okay, thank you.